Now, dear student, chapter number 10, mechanical property of fluids. And today we are starting the fluid dynamics. So here we are just starting with the basic topic that is called the streamline flow of liquid and properties along with the turbulent flow. So for it, I am just imagining a flow of liquid in a tube, and here I have mentioned a streamline, uh, and the points are here that A, B, C, and another streamline for which I have mentioned the P, Q, and R are there. As at a points I have mentioned the some tangents, and these are giving the direction of a velocity, as well as I have mentioned also the some tangent on a P, Q, and R. These also mention the magnitude of the velocity could be there. Okay, so what is the basic reason that a particular flow of a liquid is a streamline? So we are just making the some basic identification, and the first identification which we want to make here, that the particle must flow through a point which is through which the preceding particle that mean gone. Okay, so this is the first identification we have. Okay, all the particle must follow the same path which is followed by a preceding particle. Okay, so this is the first identification we have. Now the second identification, whenever they are just that passing through a particular point, so the all the particle those have gone or they will come to pass through this point, although having the same type of velocity. That means velocity to a particular point for all the particle is the same, but it could be the different at the different places. Same how Va should be the same for all the particles, but Va can be the differ from the Vb or from the Vc is there. So this is the important identification we have. Now the third identification, which is that no one particle will cross the particle which is moving ahead. Okay, or the no one particle will cross the another particle in a streamline flow. This is the another that mean prediction we have. If it is there, so the flow will not be the streamline. It can happen if you are just producing the any kind of the obstacle in the path of a streamline flow. Now the third point of the description we have that in another manner we can say that no two streamlines can cross each other. Okay, if they do that, it makes the disturbance in the steady nature of the fluid flow. Okay, now the tangent at any point on the streamline gives the direction of fluid particle. So this is another assumption we have. Now the another point, if the greater number of the streamlines are passing through a point, then the larger is the fluid velocity we have. So these are the basic identifications should kept in our mind. So the particular flow of a liquid is called the streamline flow. So how can we group that mean whole that mean theme into a that mean two or three lines? So here I am just showing it. Now when a liquid flows such that each particle of the liquid passing a given point moves along the same path and has same velocity and has the same velocity as its preceding particle, the flow or liquid is called streamline flow or steady flow. So this is the proper meaning of the streamline flow, which we can group two or the four lines, and the following characteristics should be there. Okay, so this is called the properly streamline flow we have. Now we want to discuss the turbulent flow. Now here we are just imagining the flow of a liquid is a streamline. So we should think that mean we should believe in the fact that the liquid velocity should not exceed a limiting velocity, that is called the critical velocity. So below this velocity, the liquid flow is called the streamline and the velocity is called the critical velocity. But if the velocity of a fluid exceeds from a limiting velocity, that is called the critical velocity, then the flow of a liquid will become the turbulent flow. So first we are just discussing the critical velocity, the limit velocity. So here I have mentioned the basic concept of a critical velocity. The streamline flow of is possible only if the liquid velocity does not exceed a limiting velocity is called the critical velocity. So if the liquid velocity that arises from a critical velocity, okay, or we can say that when the liquid velocity exceeds a certain limiting value called the critical velocity, the flow of the liquid becomes the zigzag. Okay, so how can we show it? And in this case, the particle will cross the that mean forwarding particle. Okay, and the two streamlines can cross each other, so the particular flow of the liquid is called the turbulent flow. And as the turbulent flow arises, so the path and the velocity of the liquid particle become the irregular. So during this turbulent flow, the vortices develop inside the water, and these vortices are known as a circulatory current, okay, and also known as a whirlpool. So how can we create a turbulent flow? So the suppose we are just getting a streamlined flow, and we are just putting a obstacle in the path of a water. This is the obstacle which I have taken in the path of the water. So the streamline will strike this one obstacle and make the irregular movement in the part of the vortices. Okay, so this is the kind of the zigzag movement of the water will arise. Here we have, okay, and the water will make the forward movement, and these are known as a vortices, and these vortices known as whirlpool. Or the simpler name of the whirlpool is that circulatory current. So this happen when the turbulent flow, and how when it happens, if the liquid velocity exceeds a limiting velocity, that is called the critical velocity, the liquid flow becomes irregular, or the and the all the particles are can cross each other, two streamlines can cross each other, and vortices develop and the whirlpool develop, and the or we can say that the circulatory current development can possible in the part of a turbulent flow. So this is the particular that mean streamline and the turbulent flow we have.